In this video, we are going to cover part 2 of Module 1, Topic 1, Lesson 5. So this is over absolute value inequalities. So by the end of part 1 and part 2, you should be able to answer these two essential questions. What are the steps to solving an absolute value equation? And what are the steps to solving an absolute value inequality? So part 1 is over equations, and if you need to go back and watch that, go back and watch that. This one is specifically going to talk about absolute value inequalities. So absolute value inequalities can take 4 different forms as shown in the table. To solve a linear absolute value inequality, you can first write it as an equivalent compound inequality. So what this means is, depending on your symbol, that is going to determine which compound inequality you have. So it's based on the inequality symbol. If you have the less than symbol, that's the first two right here, that is an and statement. What that means is whatever's in the absolute value bar will go in the middle, and you will take the negative version on the left side and the positive version on the right side. So what I like to think about for this one is, because it's less than, we say less than, because it's because it's in the middle, okay? And I know I spelled that wrong. That's done on purpose, okay? The second type comes from when you have greater than, okay? And when you have greater than, you end up having two inequalities, okay? Two different inequalities with or in the middle, okay? For when you drop the absolute value bars, you're going to have one that's less than the negative version, and then you will have one that is greater than the positive version of whatever it's equal to. So for this one, to help you remember, this will be greater, because it has an or in the middle. Okay, so in these examples, we're going to solve the linear absolute value inequality by rewriting it as an equivalent compound inequality. Then we will graph our solution on the number line. So when we go to graph our solution on the number line, we have to remember a few things. If you have the inequality signs with no line underneath, you will graph using an open circle. No line, open circle. Okay? If you have the inequalities with the or equal to, when you plot the point, you will have a closed circle. Okay? So as we go through, that's why we're going to have the inequality signs or the circles and open closed circles that we have. So here we go. First thing we need to do is we check, is the absolute value bars by itself? Nothing is being added, subtracted, multiplied, or divided. And in this case, yes, they are by themselves. Then we look at the symbol. This is a less than symbol. So because it's less than, okay, keyword emphasis on the and. That means that we are going to take this and it's going to go in the middle, okay? And we're going to take the number, the 4, and we're going to put negative 4 on the left side, positive 4 on the right side, and now we're going to solve the equation. When we go to solve the equation, we need to subtract 3, but when you subtract 3, you have to do it on all parts of the inequality. And so negative 4 minus 3 is a negative 7. You have just an x in the middle, and 4 minus 3 is just 1. And that would be your solution to the compound inequality. Okay? Now, when it comes to graphing these, you are going to put a point at negative 7 and a point at 1. But because of the inequality symbol not having a line, no line, we're going to use open circles. So I'm going to put an open circle at -7. I'm going to put an open circle at 1. And because x is in the middle of them, I am going to shade the area in the middle of the two open circles. Okay? So now let's do another one. Okay? Now, when you see one written like this, you do have to be careful. For these types of problems, we want to always make sure our x variable is on the left side. So for this, the x variable is not on the left side, so we need to rewrite it. Now, this is where people struggle. Why do we struggle with this? Because it's going to look like we're doing something that we're not actually doing. And what do I mean by that? When you go to write this inequality sign is opening up towards the absolute value. So when I rewrite it, it still has to open up towards the absolute value. And so it looks like we flipped the sign, but we really didn't flip the sign. Okay? So now, looking at this, we have a greater symbol. So this is greater. When it's greater, we're going to have two different inequality signs. Okay? When we have two different inequality signs, we're going to take the inside piece one is going to be less than and one is going to be greater than. The less than goes with the negative version of the number. The greater goes with the positive version of the number. Okay? So, then you go about solving it the same way. Okay? So, to solve this, we are going to add 4 to both sides. We have 2x is less than -2. Then we are going to divide by 2. And so we get x is less than -1. You solve the second equation, plus 4. You get 2x is greater than 10. Divide both sides by 2. And so x is greater than 5. So this is an OR, okay, OR statement. So when it's an OR statement, you are going to have 2 points like before. So we're going to go ahead and plot at -1. And this time, because the inequalities have the line underneath, these will be filled in circles. Okay, and now each one is shaded individually. Okay, and how you can tell with your shading is when your variable is on the left side, the inequality sign is telling you an arrow on which way to shade. So this is telling me to shade to the left of 1 or -1. So the left of -1 would be this way right here. And I look at the second inequality, and it's telling me to graph to the right of 5. And so that would look like this. So typically, again, there are exceptions to all of this. Typically, when you solve these types of equations, you're either going to shade in the middle area or you're going to shade on the two outside parts. Okay, there are always exceptions, but for the most part, that's what it's going to look like. Okay, so now let's look at the next one. On the next one, we have to check, is there anything being added, subtracted, or multiplied or divided to the absolute value bars? And the answer is yes, there's a 2. So we got to move that 2 first by subtracting 2 from both sides. When we subtract 2 from both sides, we get the absolute value of a -5x plus 8 is less than 23. So, based on the inequality sign, this is less than, which means we are going to write what's in the absolute value bars in the middle, and you're going to put negative 23 on the left side, positive 23 on the right side. These inequality signs always open up towards the bigger number. 23 is the bigger number. Okay? And now we go about solving. So when we solve, we are going to subtract 8, but I have to make sure that I subtract 8 from both sides. And negative 23 minus 8 is a negative 31. 23 minus 8 is 15. And now, to get x by itself, we need to divide by a negative 5. When you divide by a negative value on these inequality signs, you will need to flip the inequality signs. Again, when you divide both sides by a negative value, you need to flip the inequality signs. Because we divided by negative 5, we had to flip the inequality signs. So when we do this, negative 31 divided by negative 5 is a positive 31 over 5. Okay? And then a negative, or 15 divided by a negative 5 is a negative 3. Now, when you write this, this looks a little bit goofy because the inequality signs are opening up towards the opposite direction. So you will never see an answer written like this. What they are going to do is they are going to rearrange it where the negative number goes on the left side and the positive number goes on the right side. And so this is how you're going to see an answer for something like this. Okay? Now, go ahead and plot the points. Our inequality signs have no lines, which means no line, open circle. So we're going to put an open circle at negative 3. Then we're going to put an open circle at what 31 over 5 is, and that's about 6.2. So it's going to go about there. And because x is in the middle, we're going to shade the common area. Boom. Okay. Again, when you write your answer, you want to make sure that you go from small to big. Negative 3 is smaller than 31 over 5. Okay? Now, looking at the next one. We have the absolute value of x plus 5 is greater than negative 1. So, what I need you to know is that the absolute value, the outcome will always be positive. So what this is saying is that this is greater than negative 1. What x values is that true for? It doesn't matter what we plug in here. The number will always be greater than negative 1. So our solution for this one is all real numbers. Okay? The absolute value of any number will always be greater than negative 1. Again, the solution is all real numbers. So how would we graph all real numbers on our number line? All that's going to be is you're going to shade the whole number line with arrows because it's going to keep going in both directions forever and ever. All real numbers. I guess I should add an S to that. All real numbers. Okay? The last one. Oh, I forgot to erase the answer. Okay, there we go. So, the last one. We have the absolute value of x plus 5 is less than -1. So this is the exact opposite of what we just did. Since it's the exact opposite, what that means is that there is no solution. Why is there no solution? Because anything that comes out of that absolute value or anything that absolute value produces is going to be a positive number, which means it will never be less than -1. So that's what I'm going to write. The absolute value can never be less than -1. Okay, how would we graph that on the number line? You would leave the number line blank, and that represents that there is no solution because there's no points, no values that would ever make this true. Okay, so go ahead and answer your essential questions in the summary below, and if you have any questions, please write them down so you remember to ask me in class.